Welcome, dear friends, to the series of lectures on thermodynamics. I would be elaborating today on the concept of entropy change, which happens during a process. Mind well, I am talking about entropy change during a process and not during a cycle. So, a thermodynamic process could be a reversible thermodynamic process or an irreversible one. We know that in real life, all the processes are irreversible. So, in such a scenario, as was explained earlier, the generic expression for entropy change has to do with the heat transfer and irreversibility. So if the process is reversible, the change in entropy, so I'm denoting the entropy term by alphabet S. So ds is the change in entropy that is equal to del Q by T if the process happens to be a reversible one. If it happens to be an irreversible one, then the entropy change during a process would be higher than the corresponding entropy change during a reversible process. So this is better reflected by the expression as you see on the board, ds greater than del Q by T. So if we are talking about an irreversible process, the entropy change is given by ds is greater than del Q by T for an irreversible process. We need to ponder on, we need to think on why the other expression, that is for an irreversible process, ds is greater than del Q by T, whereas for the reversible one, it is equal to del Q by T. To understand this, I would be replacing the inequality sign by the equality sign. So the second equation, that is ds is greater than del Q by T, I can write it as ds is equal to del Q by T plus SGN. So this SGN obviously has to be a positive quantity. This has to be a positive quantity. If you want to understand what exactly is this, we need to first look at the entropy change by the two concepts. One is the concept of entropy transfer and other is the concept of entropy generation. So the entropy transfer has to do with the heat transfer. So suppose there is a system and the heat is transferred to the system. So along with the heat flows the entropy. This is because if the heat flows into the system, the molecular disorder increases. So along with the heat, there is an entropy transfer. So this entropy transfer is basically obtained by del Q by T. Del Q by T. Okay. So higher is the value of heat transfer, higher would be the value of entropy transfer. This is one important concept. The other important concept is entropy, which is created, or entropy which is generated because of the irreversibilities. Okay, for example, friction is an important irreversibility. So there would be entropy generation because of the irreversibilities, and this irreversibilities, okay, in a way are quantified. How much? We know that ideally the irreversibilities should be zero. However, no real process is an ideal process, so we will always have that during a process there will be entropy generation. So entropy change has to be because of, or let me write an elemental quantity here. So entropy change has to be because of the entropy transfer, which is the heat transfer, and entropy generation, which is the entropy change because of irreversibilities. Okay, this is the entropy generation. So if the process happens to be a reversible process, if the process happens to be a reversible process, the second term, that is entropy generation, not transfer, this is entropy generation. The entropy generation would be 0 if the process is reversible. If the process is irreversible, then we would have the quantity of entropy generation. So the entropy generation quantity has to do with the irreversibilities, and it does contribute to the change in entropy. So that is the reason why this term, that is ds of an irreversible process, is greater than del Q by T, because you have an additional quantity of entropy generation, which is a positive quantity responsible for entropy change. So mind well that entropy does change during a process, okay, either because of heat transfer, that is called as a entropy transfer, and because of the irreversibilities, which is quantified by the term entropy generation.